Friends, at the outset, I like to thank Class Academy for inviting to give a lecture on sustainable building facades. In next 40 minutes or so, I am going to talk about sustainable facade and people aware how the facade looks when you look at building from exterior in various places in this country. But the facade design has to be climate specific. Depends on the location, the facade design should vary to reap the maximum benefit on the building performance and indoor environment besides aesthetics. So you can't have a same design replicated everywhere in the country or across the globe. It should be decoded, indigenized to the local climatic condition. This is how the facade should be designed to take care of your building operational energy and building occupant comfort. What is sustainable facade? It can be defined as an exterior enclosure that use least possible amount of energy to maintain a comfort environment for the building occupants without having any negative impact to the indoor environment, and the building material what you use for the building facade designs should have very minimal negative impact to the environment. So not only operational energy performance or the building occupant comfort, the facade material should be eco-friendly, should have very minimal negative impact. You can't eliminate the effect of environment because we are using virgin material, but you should know how to compare two materials and select the one which has got very less negative impact to the environment. When you look at why you need a facade, proper facade for a building, why not just a building and leave it? It improves the building aesthetic value. You can look at different building in different locations in this country. You get a wow factor when you see from exterior to certain building. Early days we used to see LIC building in Chennai about 20-25 years back, tall building and elegant look. So that is also required. So that's why the architect play a major role in improving the aesthetic value of the building. And also the facade, due to the tropical climate in this country, we need to minimize the heat gain to the building. When you minimize the heat gain, you will be saving energy during occupancy, and also when you have facade which gives a comfort to the environment indoor, you can improve the occupant comfort and productivity. Thereby the focus should be on energy. How do you bring a daylight to the interiors? How do you provide a view to the exterior environment? How do you minimize the glare to the occupant? Otherwise you have to put the blinds and cut down the daylight and the beauty of aesthetics and work in a dark environment with artificial lighting. It should be easy to maintain. You can't bring some element for the facade and it brings a lot of difficulty for you to maintain. Acoustics is very critical when you have building across any major roads and traffic. Ventilation and aesthetic. Of course, the ventilation is playing a major role where you need to have a CO2 level is maintained and O2 level is maintained indoor so that people have a proper ventilation to breathe and operate. In a nutshell, if you look at it, what are the factors influencing the facade design? How do you choose a facade material or kind of the specification required to be maintained? One is project location and climate. What kind of climate in which your building is going to sit and operate? Orientation of the building. Building usage type. What for your building? Is it day operated or night operated? Kind of material which you are going to use it for the particular climatic condition. How you are going to finish it? And how complex is the design and application of the building? So all these important factors should be mapped right at the beginning of the building design so that you can bring the proper facade to the building. It's like person wearing a cloth. So that very, very essential to be part of right from design, the facade engineers and all other system engineers to ensure that facade is properly conceived to get the maximum benefit out of it. Let us talk one by one, like orientation, how the orientation has to be in India. For our warm climate, normally we get cool light on the north and south can be managed easily. You can't have more exposed area in east and west. If at all you have an opportunity in a site to orient your building, we normally go with a more north and south orientation and put less load on the east and west. Even if we get east and west some areas to be protected, we can create some sort of space which can be utilized for services like a service core, lift and toilet facilities will act as a heat sink, so that the heat from the east and west in the morning and evening can be arrested to large extent. So normally our exposed areas should be more of north and south. North will be a cool light. You can have more glazing to get that daylight penetration to the interior. South can be managed with some sort of facade design in terms of projection material. The orientation, once you have an orientation, normally we have two standards we follow for the glass selection. One is Energy Conservation Building Codes of India, the latest 2017 standard, and ASHRAE 2010 latest standard has come into the market. Both is defining the specification for our climate. ECBC defines our India into 4 climatic zone, and ASHRAE defines 1. But more or less we are talking about SHGC of 0.25 is a standard for India. So our study with the 400-500 building, we need to target around 0.2 to 0.25 is a solar heat gain coefficient to optimize the heat ingress to the building and bring the optimum daylight. So north, yes, though the standard says 0.25 SHGC, but north still you can relax, go up to 0.5, 0.6, but there we are getting a cool light, and rest of the areas like east and west preferably reduce it to 0.2 to maximize the benefit. Also you can have a overhanging wherever required on the facade. You can look at here, so that the projection angle can be optimized or designed based on the heat ingress and sun path study to get the sun angle hitting the bottom, not the glass. So the projection angle for the surja has to be designed so that the sun angle will never hit your glass. In that way you can get the diffuse light to the interior, not the direct heat gain to the glass, which affect your indoor building performance. So projection angle and projection depth has to be decided based on the glass height and width. So this is very, very critical for you to design a facade element with respect to the glass facade what you have in your building. And once you have this kind of light penetration, indirect light penetration, not direct, then you can have proper daylight zone to the interior, and you have to plan your interior design accordingly so that this daylight penetration to the glass, diffused one, is not controlled. Or what I mean to say is, don't put a cabins here to cut down the daylight penetration to the interior. So better to have one open offices in the northern facade side, so that north area you will get a cool light, so that all open offices can enjoy here rather than having the cabin and enclosed spaces which cut the daylight penetration to the interior. Moment you get the daylight and perform the daylight analysis, see how much is the daylight penetration based on the glass specification and window to wall ratio here. And wherever you have a daylight, try to go for daylight sensors. Once you have a daylight sensor, your artificial lighting can be controlled based on the lux what you have on the work table here. So work surface we have to design based on the type of application, and you can control the daylight penetration and optimize the artificial lighting consumption in this area. This is how the general approach for the facade design and projection or surja plus glass selection. You can see the projection angle. It will be smaller here since the window height is small, and when you have window height is more, the projection angle has to be little more, so that light will not hit the glass directly. So in particularly when you talk about other than north side, you can go up to 0.45, even 0.5 sometime, but rest of the areas you can control. Predominantly you have to reduce it to 0.2, so that the light penetration can be optimized, at the same time heat ingress can be minimized. So ultimately I look for a window to wall ratio of say around 20-30%. That is the best number to be achieved for optimizing the heat gain to the building. So 20-30% window to wall ratio is the best one to design for a building to optimize the heat gain. Then when you talk about the U factor, the three major factors we normally look at it for a glass. One is U value, second one is SHGC, the third one is, you can see here, this is what the U value, then you have an SHGC, and one more factor is a visible light transmittance. So all three to be balanced to get the best out of glass facade what you have. Glass is very vital for a building wherein we need to get the view to the exterior and the daylight penetration. At the same time, how do you optimize a heat ingress? So we normally go for lower SHGC, lower U value, higher the VLT. That's how the combination is going to be worked out for a building to optimize. This is from ASHRAE 90.1 2010 standard. Even ECBC, it classifies this 4 climatic zone: composite, hot and dry, warm, tempered and cold. So these are the major 5 climatic zones, and the factors are defined here very clearly what kind of glass needs to be selected for this building. Moment you have a facade design or the surja has been designed, these values can be a composite value, including your projection factor plus glass. Together you can even relax a little bit on your glass to get the total performance of the building. You can look at some of the facade design, what is happening, and this is an unconventional way. You would have seen all conventional designs here: plain wall, glass, recessed glaze windows, then the shading, surjas and fins, etc. These are some of the unique things. You can see the green walls, fully covered green walls, and here you can see the fins made out of wood, which is motorized, and depends on the day of the sun angle. You can adjust this blinds and control the sunlight heat ingress. At the same time, you can allow the light to penetrate, plus heat can be arrested. And this is a BIPV, building integrated photovoltaic, wherein you generate an solar the energy from the solar panels, which will arrest the heat ingress. At the same time, it allow light to penetrate. Now you have a thin film technology, you can place it on the glass, which will generate, and now the people are coming with a glass which has got inbuilt solar thin film, wherein you can generate power and also act as a glass. And this is another one R&D work is happening somewhere, I remember about in German. Algae is formed in the glass in between 2 layers, and which will arrest the heat ingress to the building and bring the beauty to the building. And this algae will be removed often to make it as a manure for garden, and again regrowth, and they supply oxygen once in a while for the algae to survive. So these are some of the unique designs are happening to bring the beauty to the building, at the same time improve the building performance and aesthetic value. What are the tools available normally we do in India? Basically, you have to go for the facade shading analysis. How the day, entire 24 hours, you can check for every day of the year, how the shading and sunlight penetration to the building. Then daylight analysis, how this facade is giving a daylight to the interior environment, wherein you can control the artificial light and save energy. Then the heat gain analysis, how the heat from the facade is having impact on your indoor environment and air conditioning load. Then sun path analysis, understand the sun angle, then you can orient your building or design your facade to cut the heat directly into the building. Then after all this analysis done, finally you come to how this building is performing overall on energy. How much is HVAC energy is consumed in this building, how much from lighting, how much from equipment. Even you can divide further into ventilation system, occupancy. So you have to bring this number, then revisit again, see how we can optimize to control this energy. So 32% in a commercial building is a good number. Can we do 29? Moment you have this analysis, you can keep revisiting and come back to the overall energy performance. So this is how the approach should be for a facade selection and implementation tomorrow for any building. And when you do the shading analysis, what shading analysis bring you onto the table for you to optimize your facade? Impact on shading devices, what kind of shading devices you have for the facade, and optimum shading. Can I go with the 600 mm Sarja or 400 mm or 200 mm or 1000 mm? That will be decided based on the shading analysis. And how much is the depth, and what will be the effective SIGC, and what will be the glass selection for a particular fin or Sarja or projection devices. So that overall impact has to be seen and implemented to not only save energy and also save on your investment part. You can look at this typical analysis performed for one of the commercial building in Andhra Pradesh. When you have a no shading devices, you can see here how the daylight penetration is happening. Some places 100, some places 77, 61, the good daylight penetration. And if it increases 300 mm, you can see again the shading impact on the overall performance, and 400 mm, 600. So you can keep increasing in your simulation package and see. Here if you overall look at it, here is the result. If there is no shading, you need to have a glass of 0.27 solar heat gain coefficient, double glaze unit. So when you increase your shading to 300 mm, you can relax on your glass, because we are shielding your glass from the direct sunlight. So 400 mm, 500, 600 mm, just you need a 0.34 SIGC, whereas no shading, same building require 0.27 to get the daylighting, to get the required energy performance. So this way you look at it, these two you can very well see 0.27 to 0.35 will definitely have an impact on your investment on the glass. This will be costlier in terms of glass performance, and this investment for 0.35 is relaxed in terms of investment. So these are the elements. So the facade translate into the glass selection investment is more critical. You can't have facade in isolation, design in isolation, and glass selection. It has to be a combination of facade pins and the selection of final glass SIGC value. This way you can optimize it. So finally, if you look at overall in this building, the 400 mm projection angle or projection depth is ideally suited for this building in Andhra Pradesh, where we optimize the investment on the glass, and also we got enough daylight penetration and saving on the HVAC during operation. So this is how the facade design needs to be conceived and implemented for a building. The next one, you can see this how the shading has impact on your the daylight penetration inside. If you can look at these 9 AM, then you can see 3 PM, 4 PM, 5 PM and 6 PM. And if you look at it after 2, if you can look at up to 3, I think 2 PM, there is no sunlight. You can see there is no penetration of sunlight. Whereas here, if you look at here, started getting this sunlight penetration inside and gradually increasing it, and 5 PM, and you can look at 6 PM, it's west orientation. When you have a west, it's a direct sunlight, the 90-degree heating on your glass. So whatever fin you provide, I am talking about vertical, you can't arrest this kind of the sunlight penetration. It has to be a vertical fins on the facade, and it should be a motorized or movable facade designed to cut down this heat gain or sunlight penetration beyond 3-4 PM. So this gives an idea for you to understand how your facade and glass really behaving in your building, and what kind of facade material I should have for different orientation to arrest the heat gain and also minimize the daylight penetration when excess daylight is coming into the building. And you can see the again the same way we did for east. The very interesting picture you can see here, the building self shading also happening. Here you can see 9 AM, there is no shading. This facade glass is fully exposed to the sun in east. When it comes to slowly, you can see here there is a self shading happening here, and slowly you can come down and see here also there is a shading happening on this facade. So this building is protected from this building, there is a shading happening. So, this glass is protected. Similarly, here it started happening. So, in that way, self shading and overshadow from the nearby building also to be really calculated, so that the facade design can be effectively implemented for the entire life of the building. So, the self shading and overshadow also has to be seen in detail when you do the facade design. And you can look at the south orientation. Here we have gone for a little more, about initially projected 1200, we optimized to 750. With the sun path analysis, you can really do this kind of study and see how much is the depth required for a particular facade. Here up to you can see almost the entire day from 9, 11, 1 p.m., 3 p.m. up to 5, it's all fully shaded in the south. So, that's what I said in the beginning, south and north can have a more exposed area and you can have more glazing. South can be treated effectively with the fins and surjas. In west, you can't do it after 4, it will hit directly on the glass. So, minimize the opening on the west and east, and you can go more on south and north to get effectively implementing the daylight penetration. And west orientation, it's similar to east. Here you can see the exposed and the areas. Yes, you have a self shading, and up to 2 p.m. you can see fully shaded. These are all shaded. You can see this glass, and moment is good after 3, you can see the sunlight is directly coming and hitting, and after 5 you can see almost it's getting exposed. So, this is where the problem in the west side, you need to have the building orientation minimum glazing on the west, so that you can avoid sunlight directly hitting on your facade and creating discomfort for the indoor environment. And north, so nowhere you can see the sunlight hitting on the glass. So, it's a completely shaded and cool light. So, here you can relax your glazing parameters like SIGC and U value, go with a more VLT and give more daylight, cool light in this north facade for the indoor environment. So, more glazing on the north is better for the building performance.